Hi, my name is Lucas Weintraub, and today I'm going to show you how to graph a parabola. So what is a parabola? A parabola is the graph of a quadratic equation. It's symmetric and it contains a minimum or maximum. Here to the right, I have shown two graphs. The first in blue is f of x equals x squared, and the one in red is f of x equals negative x squared. So since it's negative, it's flipped over, so all the values are the opposite. But it's important to know why a parabola looks like this. Why is it this curve? So I wrote down a table of numbers so that you can see how a parabola grows. So looking at the right half, you can see that even as x increases by 1, x squared increases by more each time. So here from 0 to 1, it increases by 1. 1 to 4, it's by 3. And then increases by 5, and then by 7, and then by 9, and then 11. And so it increases faster and faster each time. That's why here it goes slow, and then it goes faster and faster, and all the way into infinity. But it only goes to infinity in one direction. It only goes up. And that's because if you look at the left half, all these values of x squared are also positive, because a negative times a negative is a positive. So negative 2 squared is 4, and negative 6 squared is 36. Negative 6 squared is not negative 36. That's not how math works. And if you take the negative of that, all of these positive values of x squared become negative, except for 0, because 0 is neither positive nor negative. It's also important to note that here along this line, the y-axis, you can fold these graphs in half. So that's where they're symmetric. And also, since I told you these graphs only go up or down in a single direction, they have a minimum or a maximum depending on which direction they go. So the blue graph has a minimum. Since it only goes up, there has to be like a lowest point. Same thing for the red graph. So it goes down to negative infinity, but that means like if it only goes down, there has to be a highest point, and that's a maximum. So when graphing, there are 4 things that you need to know. There's a y-intercept, which is the value of the function evaluated at 0. The x-intercept is where the height is 0. The axis of symmetry, which is the vertical line through the middle of the parabola. And the vertex, which is the peak or valley of the parabola. And I already kind of explained that. First of all, the x-intercept is just where it crosses this horizontal line. That happens to be 0. And the y-intercept is where it crosses the vertical line. That also happens to be 0 for both of these graphs. The axis of symmetry, it's the vertical line where you can like fold it in half and it goes through the middle. And that also is x equals 0. And the vertex is the peak or valley of the parabola. And for both of these, it's also 0, 0. It's the origin. Just so you know, a vertex is a coordinate. It's a pair of points like x, y. It's not just one thing, it's 2 dimensions. So now I'm going to explain how to do this in practice. So David throws a ball in the air, and the path of the ball is described by the function negative 1 over 8 x squared plus 14 over 8x plus 15 over 8. So x is measured in meters, and assume that David is at x equals 0. So I drew a graph to show you what it looks like, and I also wrote down some questions. So A is how high is the ball right before it left David's hand? B, where does the ball touch the ground? C, when does the ball stop rising and start falling? And D, where is the peak of the ball? So these are all important questions, but you might be wondering why I already drew the graph. It's kind of like giving you the answer. Well, Even though you might want to draw a qualitative graph, kind of like the direction and maybe the shape of it, you don't know like some like numbers and like information about like where does the ball fall? What was the highest point of the ball? Where was the height here, like when before it was thrown? And that's just the same as saying where is the y-intercept or x-intercept or vertex. And that's what we're going to try to find out with these problems. It's also important to note that in a qualitative graph, you have some important things to know are like if the x squared term is positive or negative. Here, this is x squared, so it's going up, and since here it's negative, so it's going down. Right here, this is negative 1/8, so it's going down. That's how I knew that. And it's also, since it's less than 1, like 1/8, it's going slower than 1, so that means it's going to be like more spread out. If it was 8, like negative 8x squared, then it would be like super steep and going down because it's negative, but also because times 8, like you're already going to be like down here off the paper. That's why 1/8 it goes slower. And I graphed this on Desmos beforehand, so I would know. So let's do part A, which is how high is the ball right before it left David's hand. So right before the ball leaves David, it's at x equals 0. Therefore, the height is the function at 0 because f of x gives the height of the ball at x. And you can see that right here. If this is David, he's about to throw it, but it hasn't left him yet. It's at 0, and we said that David is at x equals 0, just to make things easier. So let's do that. The function is given here, and then we're going to plug in 0 for x, and then after that, we just need to simplify. So anything times 0 is 0, and so all of that cancels out. And then you're left with 15/8. And that's a really important thing to note because it was just this linear term. The height of any quadratic function is just the part with no x in it. I said linear term, I meant constant term. So that's what we're going to record right here. So at the graph, right where David is standing, this is the y-intercept. Also right before he threw the ball, it's at 0, 15/8. All right, now let's do B. So where does the ball touch the ground? The ball touches the ground at f of x equals 0. To find x, we can use the quadratic formula. You can see that here because if this is the ground, this horizontal line, the ball at this line is y equals 0, or in other words, f of x equals 0. So we just need to use the quadratic formula. Here are the values of a, b, and c, which are negative 1/8, 14/8, and 15/8. And then we just need to write down the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we just plug in all of the numbers for a, b, and c. And then you just need to do a little bit of simplification. And this function simplifies neatly, that's why I chose it. Because once you do all these square roots and multiply and then do all the things that you need to do to reduce it, you're left with -1 and 15. So that's perfect. Here, this point is 15, 0, and this point right here is -1, 0. So when the ball touched the floor, David threw it 15 meters away from him, or about 45 feet. Now we're going to do problem C, which is when does the ball stop rising and start falling. So the graph is symmetric, and therefore the point that it stops rising and falling should be in the middle. you can kind of see that visually because right before it gets to the middle, it has a positive slope, it's going up, 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 and then right after the middle, it's going down, 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 down. So the point where it switches is the middle. But how do we find the middle? The middle of the parabola is in the middle of the x-intercepts. Here, like if this is the middle right here, this is in between the x-intercepts right there. You can see that's in between those. And to figure out this value, we just need to take the average of these 2 points. So here's the formula for the average of 2 numbers, which is x1 plus x2 over 2. And then substitute in the x-intercepts, which were -1 and 15. And then you get 7. That means the axis of symmetry right here is 7. So that means at the peak was at x equals 7. So once it was 7 meters away from him, the ball was at its peak. But how high was it? We know how far away it was from him when it was at its peak, but we want to know the peak, like how high it was. And that's what question D is. So the peak of the parabola is the height of the parabola at the axis of symmetry. And to find its peak, we just evaluate it at that axis. So since the peak is the vertex, we said earlier that the vertex is a coordinate. It's the x coordinate and the y coordinate, which is the axis of symmetry, and the function evaluated at the axis of symmetry. So plug in numbers, since the axis of symmetry is 7, we plug in 7, and then you simplify and you get 8. So here's, if you want to work it out yourself. Since the coordinate of the vertex is 7, 8, we can write that down here. And we know that the highest that the ball went after David threw it was 8 meters in the air, or 24 feet. So I hope that helped. If there's anything that you found confusing or I didn't mention in the video, please comment below. And don't forget to subscribe, and I'll see you in the next video. Goodbye.